Number 1 says rewrite each equation in logarithmic form. So all we have to do is, there's not a log in it, so we're going to put a log in it. So it's going to be log with a little m, okay, because that's our base, of n equals our exponent. A key thing to remember is it always equals the exponent when we rewrite into a logarithm. Okay, it always equals our exponent. So this is our answer. That's all we had to do. Number 2, we have e to the y equals x. We want to rewrite it as a logarithm. So our base is e, then we put x, and it equals our exponent y. Now, we have to remember we can write this as something else. Log base e is special because that's the natural log, or ln, of x equals y. So that's our best answer there. Okay, so let's go the other way. Rewrite in exponential form. So I'm going to start with my base, which is 12. My exponent is what it equals, so that's x. And then I come around and pick up y. So 12 to the x equals y. If you can't do this, you will literally fail the test. Like, you do this on 80% of the problems on the test. You have to be able to rewrite it.
That's the easy part.
Okay. Well, good. That's good. Okay. ln is log with a base of e. And so we're going to have to rewrite it in exponential form. I wrote it that way so I know what my base is. Now I do e to the 4th equals y. And on each of these, like first 4, there is no solving required. So yeah, we could find out what e to the 4th is, but we don't need to because all it asked us to do was rewrite it. So we don't need to go any farther. All right, so number 5. Let's expand. So remember, expanding is where we want to have more than one logarithm. Multiplication means it's going to switch to addition. So I'm going to have log of a plus log of b plus log of c to the 4th. The other thing we want to do, though, is our exponents we want to move in front. So this is going to be log a plus log b plus 4 log c. And if you can skip straight to that last step, that's fine. You don't have to write the in-between step. Okay, so on this one looks trickier. It's the same thing at first. We're multiplying in between them. So I'm going to have log base 5 of w squared plus log base 5. But when I go to write cube root of u, I can write that as u to some power. And so I need to think cubed root is going to give me a fraction. It's the 1/3 power. And so then I'm going to take these exponents and move them in front for both of these. So this is 2 log base 5 of w plus 1/3 log base 5 of u. And I'm done. So expanding means we're going to have more than one logarithm, whereas on the next section we're condensing, and so that's going to give us just one logarithm. Yeah. Yes. Thanks. What's up?
Can you put it all over 3, or do you have to put like 1 right in front?
You can put, you'd just put the second one.
Well,
Yeah, you could. Like
And
this.
the test would be like that.
If it was multiple choice, yeah, it'd probably look like this. You can put that 3 on bottom. That's the same as 1/3. All right, let's condense. So this plus sign means that it's going to be multiplication. We're going to take the numbers in front, and those are going to be our exponents for each of these. So you can probably, most of us can do this in one step. I'm going to do it in 2. I'm going to move the exponent first on each of them. And now I have a plus sign in between, so I can make this be x to the 5th, y to the 10th inside of my logarithm. You can't combine those because they're not the same letter. Yeah.
Does it matter if you put them in parentheses?
It doesn't. I like putting parentheses personally because I think it makes it more obvious that it's log of this thing, but you don't have to put parentheses unless you have a plus or a minus sign.
Okay.
So 8 is going to do the same thing, but the minus sign means it's going to be division instead of multiplication. So see if you can do this all in one step. We got to move the exponents. So it's log base 6. On top is x to the 30th, and on bottom is y to the 5th. And since those aren't the same letter, I cannot simplify that. Like if it was x to the 30th over x to the 5th, we could simplify. But it's not. So we're not going to. Questions on 5 through 8? Okay, use a calculator to approximate each to the nearest thousandth. So you're going to get on your calculator and type math, not type math. You're going to press the math button and scroll up until you see log base. And what that's going to do is that's going to let you type this in. Like there'll be a box here and a box here, and you fill in the boxes and you get the answer. And then someone needs to tell me what that is. 2.205? Thank you. Okay, so keep in mind it does specify to round to the nearest thousandth, and that's the third decimal place. So that's what we rounded to. ln of 55, there is an ln button that you can use. You press ln 55 and then write out the decimal. No, it's okay. No, I don't want to catch. Don't throw that at me. 4.007. So those should be really easy. What just happened? Don't worry, I figured it out. Number 11, since they're both 6's, we can just get rid of the 6's and set the exponents equal to each other. Hooray! Then solve, subtract p from both sides, and get negative 4p plus 2, no, equals 2. Hang on. Negative 4p equals 2. Divide both sides by negative 4, and we get a fraction. P equals negative 1/2. Make sure that you can get that as an answer instead of having to write it as negative 0.5, because our multiple choice answers are probably going to be fractions. 12. There's actually two different ways we can do this. We can actually do this the way we're going to do 18 and 19, but because I can write 27 as 3 cubed and I can write 9 as 3 squared, there's another way I can do it. And so that relies on you being able to see that those can both be changed to that base. So 27 is 3 cubed, and then we write the exponent next to it that it already had. 9 is just 3 squared, so now they're both 3's, and I can write the exponents equal to each other. Which means I'm going to distribute. And get negative 9m minus 6 equals 2. I'm going to add 6 and then divide by negative 9. When I add 6, I get 8. When I divide by negative 9, again, you can put this in your calculator and you can get a decimal, and it's like negative 0.88888-ish. But the answer choice would probably be negative 8/9, and so that's what you want to leave it as. Now on 13 through 15, we have logarithms, so to solve them at some point we're going to have to get rid of the logarithm by rearranging. But before we do that, we need this logarithm to be by itself, so I'm going to divide by 10 on both sides. To get the log base 7 of 4n by itself, and now it equals 2. Now this 4n, you want to think of that, since it's inside the logarithm, like it's being protected by our logarithm. In other words, I can't divide by 4 on both sides right now. That's not how that works. So I'm going to rewrite this in exponential form. So my base is 7, My exponent is 2. It equals 4n, which means I'm going to divide both sides by 4 after I figure out 7 squared, which is 49. So my answer is 49/4. Again, you might have written it as 12.25, but your answer choice that you're looking for would probably be 49/4. Now 14 and 50 combine kind of two concepts because I have too many logarithms, so I need to start off by getting one single logarithm here. And since it's minus between, it's going to switch to division. Now at some point we need to think of this ln like it's log with the base of e. And you don't have to do this step, but if you notice that these will simplify to 1/4, that will give us less work in the long run. So I need to rewrite this as an exponential equation. So e is my base, it's to the 4th power, and it equals x squared over 4. And we practiced in the notes and on the worksheet not changing e to the 4th to a decimal and just keeping it as this e. So that's what we want to do. We want to times both sides by 4, which gives us 4e to the 4th, equals x squared. And then we have to think, well, how do I get rid of an x squared? Square root. So a couple things happen when I square root. One thing that happens is that I need a plus or minus sign because I need 2 answers from x squared. Then I can square root 4 and get 2. I can actually think of the square root of e to the 4th also, because e to the 4th is like having e 4 times. And so we have 2 pairs of e's, which means this would simplify to be e squared. It has been a while since we've done that, so I would understand if that's a little hazy for you. But we should get positive and negative 2e squared. Also on these, we should be kind of keeping in mind that if we plug it back in, we should get positives inside of our logarithm, which on both of these that happens. 14, what's nice is what we put in immediately gets squared, so the only answer that would be wrong on 14 would be 0, because 0 is not positive. So 15 is like 14, except instead of us having a minus sign, it's a plus sign. So that's going to change it to multiplication. And so at some point we need to think of this like log base e. We can do 36 times 7 and get 21x. And then we're going to rewrite it in exponential form. So that's e to the 5th equals 21x. Again, we could find e to the 5th on our calculator, but we're just going to leave it and divide both sides by 21. The idea is that if we leave it as e, then we won't have rounded anything, which mathematicians really like, not having to round. So that's why we would leave it with the e instead of plugging it into our calculator. If you really have problems with that, with writing it like that, if that doesn't make sense to you, you could find the decimal, and if it is multiple choice, you could put those in your calculator and see which one gives you what you got. So there is kind of a way around it if it makes you super uncomfortable to see e to the 5th over 21. Next page. Now on these it says solve each equation, round your answers to the nearest 10,000th. That's 4 decimal places. I definitely want at least 3. If you forget to put the 4th one, that's fine, because in class we pretty much just did 3 decimal places. But 1 decimal place is not okay. To solve this, since my exponent has my variable, I need to rewrite this as a logarithm. So it's going to be log base e of 5 equals 4v. So remember I said if you can't rearrange these, you're going to fail the test, because almost every single problem we've had to rearrange at some point. This is something I can plug into my calculator. I can also actually, instead of putting log base e of 5, I could type in ln of 5, because those mean the same thing. You don't have to switch it to ln. You can put in log base e of 5. Whatever you want to do there is fine. What is ln of 5. 1.609. And then we need to divide both sides by 4. So remember to just make it do answer divided by 4. And we get 0.4024. And we haven't been doing this very much, but if you did want to check, like you can go back and plug in what you just got. Well, I mean for the test, you know, because it's a test. If you wanted to. If you type this in, now if I type in 0.4024, it's probably going to give me something really close to 5. We'd have to actually put in our answer for it to be 5, our answer from our calculator. So 17, rearrange this into a logarithm. Log base e of 93 equals x minus 6. So I need to find log base e of 93 on my calculator. Or you can think of this like it's ln of 93. And once we do that, we're going to add 6 to both sides. So what is the natural log of 93?
4.532599493.
Thanks. And then I need to add 6 to both sides, which I can actually do that in my head, 10.5326. Okay, so on 18 and 19, we're doing the same thing, except now, for one thing, I don't have that e, which might make you happy, I don't know. But now my exponential part is not by itself. So I need to start off by adding 10 on both sides, so that I get 16 to the 2b equals 86. And then we got to rearrange it because our variable is in our exponent and we need to get it out. So it's log with a base of 16 of 86 equals 2b. And this is normally where I would make a 2b or not to be joke. Yeah. So I'm going to plug this into my calculator. So this I have to go to math and I have to scroll up to type that in. And then once I figure out what that is, I'm going to divide it by 2. So log base 16 of 86. 1.6066 equals 2b. So I'm going to divide both sides by 2. 0.8033.
Could you leave it as like 1.6066 over 2?
I guess if it was free response, you could. But if it was multiple choice, you'd have to look for the 0.8033. 19, we have 19 to the n plus 10 to get by itself. So we divide by 7 first and get 6, and then rewrite it as a logarithm. Log base 19 of 6 equals n plus 10. So we'll have to do the left side in our calculator and then subtract 10 on both sides. So log base 19 of 6. Anybody know what that is?
What? Say it again.
Point,
Divided by the
0.6. 0.6, was there an O?
Yes.
0.6085 equals n plus 10. Then I subtract 10 from both sides. And n equals, so go ahead and subtract 10 on your calculator because that's a little tricky. Negative 9.391. Number 20. Now that might look a little intimidating, but what they're doing is they're telling us a formula to use for us to figure out how many milligrams of some drug, we'll call it Tylenol, how much would remain in the patient's bloodstream after 7 hours, okay? So that means that T is 7. And so we can actually type this all into our calculator at the same time. We type 30 and then the E button and an exponent and then negative 0.3 times 7. And you get 3.6, which it doesn't tell us what to round to. So we could round to 1 decimal place if we wanted to, 3.7 milligrams. Okay, so at 5% annual interest, that's R, and we have to change it to a decimal to 0.05. Compounded continuously, that's how we know to use this formula, but also that's right there in the problem, so that's the other reason we know to use that formula. How long will it take for a $50 investment to be worth $200? So the amount we're depositing is 50, and we want to get 200, and they're asking us how much time will that take. So let's plug it in. And since we don't know t, that's going to stay a t. Or I guess you could put an x there if you wanted to. But to solve this, we would divide by 50. This is going to actually be similar to like 16 through 19, how we solved. 200 divided by 50 is 4. And then once we have this e by itself, we need to rewrite this in in logarithmic form. It's in exponential form. So rewrite it as log base e of 4 equals 0.05t. So we can figure out this on the left side and then divide by 0.05. And remember, log base e of 4, you can type in ln of 4 and that'll give you the answer. That's going to be 1.386 equals 0.05t. Divide by 0.05 and you get 27.7. You can round to 28. I told you guys with years you could round to the nearest year, and that's fine. If it doesn't specify what to round to, I don't really care what you round to.
So what do you do with the 0.05?
I divided it, sorry.
I was just,
I divided by 0.05.
that's not cool.
All right, so Rita deposits $3,000, so that's P, in a bank account at 8%. So I'm going to put 0.08. Compounded semi-annually. So that's where this n comes in. Okay, so we need to think about how many times in a year does semi-annually happen? 2. And then it wants to know how long it takes to earn $1,500 in interest. Well, A is how much is in our account. So if we start with 3,000 and we add to that 1,500, how much do we have? 4,500. If you put 1,500 here for A, you're going to get a negative number, which hopefully you realize is bad because we can't have negative time yet. Maybe someday. Anyway, so we plug this in. And this might seem tricky to solve for t, but we're going to do 2 things to make it easier. We're going to divide by 3,000. Which is 1.5. And then I'm going to do this part in parentheses. 1 plus 0.08 over 2 is 1.04.
Wait, did you subtract the 3,000?
I divided the 3,000. Because it was being multiplied, so I have to divide it. But this right here, I stuck in the calculator. Now I can rewrite this as a logarithm. You might be noticing a theme of rewriting things as logarithms. Kind of a big deal. So I'm going to figure out what this is. 1.04. I'm sorry, but it's a 4. So just so you know, it's a 4. I didn't mean that harshly. It just came across that way. So you get 10.338 equals 2t, so I have to divide by 2. 5.2 or 5 years. yours. 23, 24, and 25 are from our last test. So remember, if you do better on this test than you did on the last test, then it replaces your grade. So find the inverse. We have to switch x and y around and then solve for y. This is not the same as having 5 times y. I can't just divide by 5 on both sides. I have to rewrite this as a logarithm. And if it helps you to rewrite this like this, 5 to the y equals x, and then change it to a logarithm, then be my guest. So we get y equals log base 5 of x.
That was an easy one.
So let's try this one. We're going to switch x and y.
I don't want to say.
And since our logarithm is by itself, we can rewrite this in exponential form. This would be 4 to the x equals y plus 9. And then I'm not solved for y yet. I have to subtract the 9 over. So I get 4 to the x minus 9 equals y, and that's my answer. I can't actually do anything with 4 to the x minus 9, since those aren't the same number. Even if they were the same number, I wouldn't want to do anything with them. Oops. All right, so we're going to sketch this graph. So you're going to type it into y equals. Remember to go to math and scroll up to log base. And you can look at the picture of it, but what's really important is our table of values. We get 4 comma negative 3 and 8 comma negative 2. And so our graph will go to the right and will go up slowly to the right. To the left, on our calculator, it just shows it ending, but we have to remember it ends up going straight down. Okay? The calculator's not smart enough to show us that, so we have to remember that ourselves. And the way I know what line it's getting close to here is if I look at my table of values, there's all of these errors, and the last error is at 3. So this is the important point. On my domain, I put 3 comma infinity because I almost am at 3, okay, and I can plug in any value from close to 3 onto the biggest number I can think of, and I can get an answer into this logarithm. But it has to be more than 3. You wouldn't put 4 here because 4 would be saying that it didn't touch 4, but we have a point at 4. The range is our y values, and that's our up and down. It goes down forever, and since it's going up and right, it's going to go up forever also. So that's negative infinity comma positive infinity.